Hello and welcome to your preview of Training to Go modules presented by Technical Sales and Consulting. At the end of the preview, we will provide how to access more information about our training products. Thanks for visiting, and we hope you enjoy the preview. Some transformers are furnished with dual windings to allow flexibility for different voltage connections in the field. Here's a typical wiring diagram for dual primary and dual secondary windings. This transformer can be connected to a source voltage of 240 or 480 volts, and the secondary can be connected to a load rated at 120 or 240 volts. Here's how. If the source voltage is 480, then H2 and H3 can be jumpered, and the line can be connected to H1 and H4. If 240 volts, then H1 and H3 are jumpered, and H2 and H4 are also jumpered, and the line is again connected to H1 and H4. On the secondary side, if 240 volts is desired, then X2 and X3 are jumpered together, while the load is connected to X1 and X4. If 120 volts is required, then X1 and X3 are jumpered, also X2 and X4 are jumpered, and the load again is connected to X1 and X4. Here is an explanation of how taps can be changed. The source voltage can be higher or lower when supplied by the utility. Taps allow for application flexibility and allow the user to change the primary winding to compensate for the voltage difference. Taps are usually available in either 2.5% or 5% increments above and below normal. Let's look at a standard dry type distribution transformer with two 2.5% taps above and two 2.5% taps below normal. The primary wiring diagram looks like this. Let's assume that the rated voltage is 480 volts. 2.5% of 480 would be 12 volts, making the above normal taps available at 492 and 504 volts. To achieve a matching turns ratio for 504 volts, the source lines are connected to H1 and H5, and for 492 volts, the lines are connected to H1 and H4. Normal 480 volt connections are to H1 and H3. Now, below normal taps are available at 468 and 456 volts. To use the 468 volt tap connection, the line must be connected to H2 and H4. The last below normal tap would be 456 volts, and the lines would be connected to H2 and H3. All of these connections will ensure that the secondary voltage will remain constant. Hi, we hope you enjoyed a sample video of our online e-learning module. This clip is from one of our many available modules. We're always working on new modules, but here is the current list of developed lessons. Low voltage motor control, molded case circuit breakers, insulated case circuit breakers, low voltage power breakers, medium voltage switchgear, medium voltage control, motor control centers, transformers, contactors, operators devices, protective relays, and lastly, variable frequency drives. Outlines, pricing, previews, and requests for information are available at tsnc.com/e-learning. Let our Training to Go programs train your people while you run your business.